All right, boys and girls, I'm going to go ahead and repeat the first part of the notes just in case you didn't quite get the video, and it's all condensed into one, okay? So here we go. I highlighted a few things that are important. So again, I want to remind you, a relation is basically a pairing of elements, okay? So it's just when you pair things. And then your domain are called inputs, and the range are called outputs, okay? A one-to-one function is where no output is ever used more than once. Again, no output is ever used more than once, okay? And a many-to-one function is at least one output is used more than once, okay? Here we go. And okay, and then the other thing is an inverse relation reverses the pairings. Okay, that's the key word, reverses the pairings. And the inverse function is written this way, and you read it f inverse of x. Okay, that little exponent with the -1 is read as inverse. Okay, and this is already worked out for you. Okay, you can take a look at this. It's worked out for you. So, okay, so I want to remind you, your domain values are called x's or inputs. Your y values are called outputs or range, okay? And this is considered a one-to-one function because every input has exactly one output. Every one input has exactly one output, okay? And this is an inverse function. And again, we talked about how the domains in the list here used to be the range in the first function, okay? They just reversed each other. And the range here used to be the domain here. So they just reverse each other, okay? All right, awesome. Okay. And then here we had two boxes that were empty, but those values are 0 and 1. And again, I just got them from over here from my domain values, okay? Notice right here I wrote a point, -4, -2, because these are my x's and these are my y's. If I write it as a point, this is what it would look like, okay? And then the second question they asked is the inverse still a function? And then explain, and I said yes. Every domain has a unique range. So it's basically the same thing. I just wrote it a little bit different. So every input has exactly one output. So it's still a function, okay? So this one works out. All right, moving on to the second one. Okay. In this function, we have what's called many to one. See, many to one. So two different inputs have the same output. And of course, over here, the domain used to be the range, and over here, the range used to be the domain. And of course, we had to fill in the values, okay? So over here, they asked you, why is it many to one? And that's because more than one input has the same output value, okay? And then, is the inverse a function? And the answer is no, okay? And I apologize because I feel like I made a mistake saying something out loud last time. And so I'm just going to correct it now. You probably won't even know the mistake. You probably didn't even catch it, but let me explain. So earlier I kind of said, one way to help you remember is think of domains as students, think of range as grades, okay? You have to put in the work to get your grade. So you input work and output, you get your grade. That's your result. So two different students and have the same grade. That works. That's perfect. But over here, the same student cannot have two different grades in the class. That won't happen. You can't have an A and an F. So, that doesn't work out. So what happens is this is a function. This is not a function. The moment you do the inverse of this, it's not a function, okay? And that's because your x value technically repeats, okay? Or the same input has more than one output, okay? So same input has more than one output. So if I were to write the points down, I would have -3, -4, -3, 0, 2, 1, and 2, 4, okay? notice your x is repeated. That can't happen, okay? That's kind of where I mentioned the wrong letter on the video, okay? So it doesn't matter if your y's repeat, because notice over here, if I were to write the points, I would have 1, 2, and then 4 would also have 2. And that's okay. Oops, apologize. It's okay if your y values repeat. What it can't repeat are your x values. And just remember that little hint. Two different students can have the same grade, see? But one student can have two different grades. So this input has two different values, and that can happen. So not a function, and this is a function. All right? Awesome. All right, let's move on to the next part. Okay, in the next part, I'm going to show you how to graph your functions and also graph your inverse functions. Okay, so you are going to need a ruler. You are going to need graphing paper. I can tell you you're probably going to need a lot of graphing paper in this class. So you might want to purchase some graphing paper, okay? Invest in a ruler and graphing paper. All right, for the first part, composition, don't worry about that. We will do that tomorrow, okay? So we're just going to concentrate on explain 1. Explain 1 has 4 different steps on finding the inverse of a function. So here's what you have to remember. Substitute y for x is step 1. Solve x in terms of y. Switch x and y. And replace y with f inverse of x. Okay? Remember these 4 steps. You might even want to write them on an index card and then just try to memorize them, okay? Most of the work will come from step 2, okay? So here we go. I'm going to lift this up, and what I did is in part A, I have our function, and then I broke it down into 4 parts, so that way you could see the work for everything. Notice I left a lot of space between 2. That's because all the work is in step 2. And I'm going to use a pencil, so if I mess up, I can easily erase, okay? All right, here we go. Ready? Our function is f of x equals 3x plus 4. Step 1, substitute y for x. That's it. Step 2, solve for x in terms of y. So what we're going to do is we're going to isolate x, get it by itself. So I'm going to subtract 4 to both sides. And then I'm left with y minus 4 equals 3x. And then I'm going to divide 3 to both sides. And when I divide it, I'm just going to do it this way. You can also divide them individually, but I'm just going to go ahead and do it this way for now. Okay? So my answer should be y minus 4 over 3 equals x. Okay? Or x equals y minus 4 over 3. Okay? And then step 4... step 3, that was step 2. Step 3 says switch x and y. So now what we're going to do is you're just going to switch these letters. So now we're going to have y equals x minus 4 over 3. And then our very last step, step 4, is simply to switch y with f inverse. So now it's going to read f inverse of x equals x minus y over 3. And this is my inverse. Okay. If you didn't quite get it, hopefully you're taking notes and at least following along. We're going to do a couple more together, okay? So I'm going to go back to the directions. The directions say to find the inverse, which we did, and then is use composition. Don't worry about this part. Ignore that part. We will do that tomorrow. All we're going to do next is then graph, okay? We're going to graph the function. So what I did, this is not necessary, but it might be helpful for some of you. What I did is I did a table, okay? Notice they're exactly the same. Use one of them for your original function and use the other one for your inverse function, okay? It's up to you. If you have a graphing calculator, it's going to make everything easy. If you don't have a graphing calculator, I'm going to show you how to graph first without a graphing calculator because I'm going to assume you don't have one, okay? So here we go. And again, if I would get a ruler, or if you don't have a ruler, just use a straight edge, okay? All right. I don't have a ruler with me right now, so I'm going to use an index card, okay? So I'm just going to improvise and do with what I have. Okay, here we go. we're going to graph f of x equals 3x plus 4. If you recall, in integrated 1, you used to have this equation, y equals mx plus b, where m stands for slope and b stands for y-intercept. Okay, by now you guys should all be experts in graphing this, and it's going to make things a lot easier. And then you won't need a chart, okay? But I'm going to show you how to use that regardless. Okay, here we go. This is super easy to graph, so I'm going to go ahead and just start graphing it, okay? Now, if you're wondering, what is this line right here? You're going to think of this line. Oops, excuse me. Think of this line as your axis of symmetry. Okay. Axis of symmetry, or your mirror. It's going to act as a mirror. Okay. And it'll make sense in a minute. So you just have to kind of ignore that line. Pretend it's not there. I'm going to go ahead and use a red pen for now. And I'm just going to graph the first line. So we're going to start at point 4. Okay. Because that's my y-intercept. And then from there, my slope is 3. So I would normally go up 3 and to the right 1, but I don't have enough room. So when that happens, you just do the complete opposite. Go down 3. 1, 2, 3, but please don't go to the right. Go to the left 1. And I'm going to keep going. 1, 2, 3 to the left 1. And then 1, 2, 3 and to the left 1. If you're wondering, when do you stop? You need at least 2 points to draw a line. The more points you draw, the better you are. Okay. Once you draw that line, go ahead and get a straight edge and do your best to connect them. Okay. I like to make sure they go off the grid. Okay. And this is your function, your f of x. Okay. And remember, my slope is positive, so my line should be rising, okay? Should be rising, going up from left to right. So that's my function, okay? Now, if you're wondering, how do you graph this line? And you know what? I just made a mistake. My y here, my y should have been a 4, and I made it look like a y. But, of course, we're not in the classroom, so nobody could tell me. But I just looked at it again. I apologize. Okay, that should be a 4. All right, so it's x minus 4 over 3. If you are someone who is like, I don't know how to graph this, then that's okay. So I would do a couple of things. I would rewrite it as x over 3 minus 4 over 3. Okay, sometimes this works, sometimes it doesn't work. Okay, you'll know, trust me. So this is my slope. 1 over 3x, and that's easy because I'll rise 1, run 3. But then my point here, this is like 1 1/3, which is going to give me a decimal. And so it's kind of a weird number and kind of a weird way to graph. And you're thinking, I don't know how to graph that. That's okay. Then you go to the alternative, okay? And I'm actually not going to graph that because I think that's weird to graph 1 1/3. So I'm going to give you the alternative. This is when I use my tables, okay? So remember, we're going to use the first table as my function, and this is going to be the inverse. So what I'm going to do is I'm going to fill in a couple of points. And if you're wondering where do I get these points, I'm going to get them from my graph. Notice I graphed 1, 2, 3, 4. I plotted 4 points on that line. So what are my 4 points that I plotted? -3, -3 and -5, -1, 1, and 0, 0, 4. So I'm going to write all those down here. Okay, so here we go. I said -3, -5, -2, -2, -1, 1, and 0, 4. Okay. Now remember, I have 5 spaces. If I want more points, I can have more points. All you need is at least 2. Remember, these are my x's, these are my y's. So if you recall, previously I showed you that your inverse function should just be the reverse of these. So all I have to do is now flip my points. So now I'm going to have -5, -3, -2, -2, 1, negative 1, and 4, 0. And now that I have all the points for my inverse, now I can go ahead and plot those points, okay? Which makes it a lot easier to plot this than this, okay? So at least I have my inverse function, but I don't plot that. I plot this, okay? Do I need to plot all 4? No. Can I plot just 3? Yes. Can I plot just 2? Yes, because all you need is 2 points to draw a line, okay? The more points you plot, the better. So I'm just going to go ahead and just plot 3. So I'm going to plot negative 2, which is going to be, oops, let me go over here, which is going to be the exact same point. So it's going to overlap. 1 right here, negative 1, and then 4, 0. Okay. So those are my 3 points. So now I'm going to graph my index card. And I am going to draw my line. And this is my F inverse of X. Okay. Now, you're going to be on your own and you're going to be wondering, oh my gosh, Miss Frias, how did you do that? And how do I know if I'm right? First of all, I'm going to ask you to just follow along for the first one and not take notes, just watch. And then maybe afterwards copy it or then try the second one. But here's a way you could tell if you drew it correctly. Tomorrow I'm going to show you composition, which is another way of checking your work. But here's how you can tell. If you can imagine folding this graph downwards this way, as if this is the folding part, okay? Remember earlier I said this is going to act like your mirror? Are these reflections of each other? Do you think they will overlap over each other? Will the red overlap on the black? Will the black overlap in the red and vice versa? If you imagine folding it and you think it will, then you did it correctly. If you could tell, mine's the same spacing should be here, okay? If I fold them down here, they should overlap, okay? That's how you know you did it correctly. All right, guys, we are going to move on to the next one. Ignore composition. We will do composition tomorrow, okay? All right, boys and girls, we're going to try the second one now. So we're going to try f of x equals 2x minus 2. And the first thing we're going to do is we're going to do the inverse, okay? So remember, it says substitute y for f of x. So y equals 2x minus 2. Step 2, solve for x in terms of y. So all that means is just isolate x, get x by itself. So we're going to add 2 to both sides. And so then we're left with y plus 2 equals 2x. And then to get x by itself, we're going to divide by 2. Okay? So we're going to be left with y plus 2 over 2 equals x. So this is kind of a prelude. If you know you're going to be graphing this later on, remember what I said. See how I divided everything by 2? I can just divide every single term by 2, and this is what it's going to look like. Y over 2 plus 2 over 2. And guys, 2 over 2 simplifies to 1. So this would be y over 2 plus 1 equals x. Okay? All right. So this is just me simplifying it, okay? Now in step 3, it says switch x and y. So now instead of saying x equals this, I'm going to write y equals y over 2 plus 1. Now if you're wondering, oh my gosh, Miss Frias, why did you split it up and you didn't do that last time? Because remember, now you know you're going to have to be graphing it. So it's easier to, there I go. You guys are not in the classroom, so it's hard for me to catch my mistakes. So remember, we're going to be graphing it. So I want a slope and I want a y-intercept. So I might as well split it up now. Okay. All right. And then the last step just says replace y with f inverse. So instead of y, we're going to have f inverse of x equals x over 2 plus 1. Okay. Now remember, we're going to be graphing it. So some of you are like, what is x over 2? X over 2 is the same as if I were to write 1 over 2 times x. So this is your slope. Remember, your slope is rise over run. Okay? Plus 1. Okay? All right, so here we go. Let's start graphing. So remember last time I said slope and y-intercept. Your slope is 2, your y-intercept is -2. So when I come and graph it, I'm going to start at -2, and then I'm going to rise 2. 1, 2, and run 1. 1, 2, and run 1. 1, 2, and run 1. Again, I plotted 4 points, which is more than enough. So now I'm going to... Sorry, I keep hitting my phone. I'm just going to extend it. This is my original. This is my f of x. Okay, this is this one. Now, do I need a chart this time? No. Sometimes you need it. It's there if you need it. If you don't need it, don't use it. That's up to you. Completely up to you, okay? Because now I can graph this using the same concept. Slope and y-intercept. Rise over run and y-intercept, okay? So here we go. Ready? We're going to start at 1. And 1 is right here, okay? And my slope is 1. So I'm going to write... Sorry, I'm going to go up 1 and run 2. 1, 2. Up 1 and run 2. 1, 2. Okay, now if I want to keep going, up 1 and run 2, see how I run out of room, but I'm like, oh, I want one more point. Then I can go back to the original and use your slope, but go completely opposite. Instead of up 1, go down 1. Instead of right, go to the left 2. Down 1 to the left 2. Down 1 to the left 2, okay? You have to imagine a line. So now I'm going to take my index card, connect my points. Oops. Oh my gosh. What was the point of that? Sorry, my phone is super close. I'm trying not to hit it. And this is f inverse of x. Okay. Hopefully you're looking at that first line. Again, I want to remind you, if you're wondering, how do I know if you're doing it correctly? Just imagine, do these lines overlap? If it's not obvious, if it looks like, wait a minute, they don't quite look like they overlap, then double check your work because they should look like they overlapped, okay? If it's way off, then you know you did something wrong, okay? If you have a graphing calculator by any chance, you can also check your work. So I'm going to show you how to do that with the graphing calculator. I don't expect or assume that all of you do, but you can also use Desmos to check your work. So here we go. Where it says y equals, I'm going to put my first function, 2x minus 2. And then my second function, I'm going to put my equation. So 1/2 x plus 1. Or you can do it as a fraction. Oops. Let me get out of that. Sorry. Is x divided by 2. Okay. Like I have it originally. Oops. Like I have it originally. X over 2 if you don't like that. Plus 1. Just make sure you have it in parentheses. Or you can use, if you're really good at using a graphing calculator, let me clear that. If you go to math, see how it says fraction? N over D will literally write a fraction for you. So you can write x over 2 plus 1. Okay? So I kind of showed you some options. And then press graph. And you know, it's going to keep graphing until that little circle, the little torture wheel is what I call it, is done. Okay? So it's done. And basically this is what it should look like. And I like that it's color coded too. Okay? And then if you're still like, but Miss Riz, but how do I know I did it right? Well, look, you can go to the table, second and graph, and then look at your points. All the points, all the x's are the same x's in both, but look at your y's. They should be, See, when x is 3 here, y is 4. So now in the red one, I believe that was our second one. So now remember, they're going to flip. So go to 4. When x is 4, look, it should be 3 here, because remember, you have to flip them. Okay, so you can check that way. All right, guys, hopefully this makes sense. Notice I didn't use the table, which is a good thing. Again, sometimes you'll need it, sometimes you won't. That's kind of up to you. Skip composition because we'll do that tomorrow. All right. Now I'm going to have you guys try the last page where it says your turn, okay? Notice I didn't write the work because now you're supposed to memorize that, okay? But use your notes. So find the inverse and then graph them, okay? So do me a favor, pause the video, try it on your own, and then come back for the answer. All right, boys and girls, this is what it should look like. Notice here I broke it down into the 4 steps. You can pause the video, take a look at it. But basically, my inverse function should be f inverse of x equals negative x over 2 plus 3 over 2. Okay? I went ahead and separated. When I separated and I see that the numerator is larger than the denominator, I know that I'm going to get a decimal. And I don't like to graph my intercepts at decimal because then I'm just kind of estimating. So instead of using that for me to graph, I'm going to use the tables. Okay, so I'll show you. I did go ahead and graph the function with slope and y-intercept. So there it is. And it is negative. So it's decreasing. It's going from left to right. It's going down. Okay. And this is my f inverse. So when I go down to the table, I did use the table because, like I said, when I get something like that, kind of y-intercept where it's a decimal or a fraction, it's hard for me to graph, okay? I only like to graph whole numbers. So I picked out 3 points from f of x, and then which gave me my f inverse. Remember, you just switch them, okay? Just flip them. And then these points are much easier to graph than to try to graph a decimal or a fraction, okay? And then I plotted it. So this is what it looks like. Okay. All right, boys and girls, that's all you need to be able to graph for today. Composition, we will do tomorrow. Okay. And that's just another way to verify that what you're doing is correct. All right. You have enough to do your classwork for today. Go ahead and get started. If you need help, come see me. All right. Have a nice day. Good luck.